Greetings from Terry, here at D-lab Electronics. Weekend project is a pair of Dynaco MKIII monoblock amplifiers running KT-88 tubes. This system was purchased by a friend of mine. He brought them by here for me to go through the system, retube them, check the caps, power supply, etc., and make sure that they are fully serviceable before he puts them into use. So here we go, a real cool adventure on a Dynaco. So here's the little monoblocks. Got unit A and unit B, and what's really cool is the guy that sold this system also packaged all the tubes identifying what amp they went into. Now I do have some new Genelex Gold Lion KT-88s here that are going to go in the amp, but first off we're going to make sure that these things are alive and that the bias circuits are working before we do a thermal meltdown. As you can see here, the filter caps have been changed, which is a very good thing. Now if you look at the driver boards though, you'll see they still got the old Black Beauty caps. Those are coming out, because if these caps are leaking and you put in your new output tubes, you're going to flame them out, right? We don't want that to happen. So I do have some new sprayed orange drops here to go into those positions. So the next thing I need to do is pop the bottom, give these things an inspection, and then we'll check the power supplies, insert caps, tubes, etc., and bring these guys up. Okay, we're going to start off with unit A. We're going to give it a thorough inspection, and one thing I wanted to point out, you can see that it still has the original loudspeaker jacks here on the back, which are nothing more than screw terminals. A lot of people take these off and put these big ugly banana jacks on the back. I really don't like that, so it's good to see that the rear panel is stock. Internal wise, construction looks great. You can see a little bit of heating here on the board, so I want to take and really inspect the solder connections, make sure we don't have any cracks. These caps here have been changed in the bias circuit, so that's a good thing. Whoever did the recap job, they did good work. I don't see any issues under here so far. So let me give her an inspection and we'll cut back to the initial power up with no tubes installed, because I just need to verify that the transformers are alive. I've completed my visual inspection on unit A, and I don't see anything that looks out of place or to be concerned with. But one thing I wanted to point out is if you take a look up here, remember I told you that the filter caps were replaced, okay? So here is the new filter cap. Now if you notice, the ground lugs are not soldered, okay? Now normally in older amps you would see these lugs here that are twisted, they would be soldered to the chassis. But in this case, you can't do it because this thing's chrome plated and solder won't stick to it. So if you replace these caps, make sure that you do like they did here. This is a ground runner that goes over to this tube socket, which makes a mechanical connection to ground. So that's about the best you can do, but also make sure that all the hardware on these tube sockets and like this terminal board, make sure all this stuff is tight, because if it's not and you lose that negative bias, guess what happens to your output tubes? So the next step here, I've connected my meter AC volts to pins 4 and 6 of the rectifier tube socket. Okay, the tube is not installed, and I got it over here on a variac. All right, so I'm just going to take this and bump the voltage up and down and make sure that I see the high voltage, which I do. Now I'm going to swap my leads over to pins 2 and 8 and make sure that the 5 volts is present for the filament of the rectifier tube. Same thing. I'm just going to bring her up, bump the voltage, and there it is. So both windings are alive. So that's a good thing. Next, I'm going to put in the rectifier tube. We're going to bring this thing up slowly. I'm going to put a load on the high voltage so that it would discharge when I'm done. And we're going to check things like the negative bias, and we're going to make sure that we have DC going through the primary of the output transformer. So that will verify that everything's present before I insert tubes. Alright, now what we have going on is I'm going to check the DC output off the power supply. The rectifier tube, the 5AR4, is installed. I've got my meter monitoring the output that goes to the filter cap, and in here I've got a 40K resistor at about 25 watts, and that is connected to pin 3 of one of the output tubes. So that is going to dissipate the high voltage once I shut it down so that it's safe. So once again, I've got it on the variac. Alright, there's the variac. I'm going to bring her up slowly. We're going to watch the meter. We're looking for high voltage. Now you got to bring this up quite high because you have to heat the filaments on the rectifier tube before you start developing DC. Alright, so you can see the meter starting to act. I'm at about 70 volts right there input. So once it heats up, you'll see the high voltage come up quicker. Right now she's kind of creeping. There's about 80 volts. So yep, see the high voltage coming on up. That's a good thing. Now I'm going to kill it because what I want to see next is the voltage that's on the output tubes, pin 3, because that will verify that the primary of my output transformer is okay. So I've connected my lead to pin 3. Now if you're going to do this, use extreme caution. Don't let that probe short to other terminals where you're going to have some fireworks and possibly damage your power supply, right? So I'm going to bring her up. So we're looking at the first output tube, pin 3. We're looking for high voltage. Remember, I'm on the variac. So it's going to be a slow process because I want to protect this thing. So you can see the high voltage coming up on that pin 3. That's good. I'm going to ramp it down. Then we'll move the probe to the other pin 3 that has the load resistor. Okay? We're going to do the same thing. Bring the high voltage back up. And yes, it's there. Take it back on down. Next, I'm going to check the screen circuits. So I move my probe to pin 4 with the same tube that has load resistor. Bringing up the variac. You can see the high voltage coming up. So we have screen voltage. Let's take it on back down. Same deal. I'm going to move my probe to the first tube, make sure nothing shorts out. Bring her back up. Yep, we've got screen voltage. So those are two good things. But the most critical thing is, do we have negative bias? Because that is what holds down those output tubes so they don't go up in flames. So we're going to check that next. So the negative bias comes in here. You can see on pins 6 and 5. So it actually goes to 6 through the 1K resistor to pin 5, which is the grid of these output tubes, right? So in this case, we're looking for negative voltage. Now this is going to come up pretty quick because it does not rely on the 5AR4. So watch how fast it comes up. So that's a good thing. We got negative bias, right? Same deal. Let it dissipate, and then we're going to move to the other tube and make sure got that negative bias. And we do. So I would say at this point we are safe to install some tubes, bring this thing up, set the bias, and check for output. So at this point we know that the power supply is working, rectifier tube's okay, got a good filter cap, our negative bias is there, we have screen and plate voltage. But before I put in tubes and bring this guy up, I'm going to change these caps. These black beauties are notorious for leakage, and if you put in new output tubes, it may not happen immediately, but soon as you're playing your amp, sure enough, I guarantee you're going to look over and say, man, why is one of my output tubes turning orange and it's running hotter than all get out? And at that point, it's too late. So spend the $5, whatever it costs to change these 3 caps, change them out. And if you're a collector, put them in a bag and keep them. But I don't run these old caps. So let's move on. Removal of these driver board caps is a fairly simple process because you can actually pop them right up from the top of the board. It's because Dynaco, when they designed this board, they use these nice little metal vias, kind of like the eyelets that you would see on an old Fender amp. So removal and replacement of the components is fairly easy. You can drop these back in through the top, but then of course you want to flip it underneath, take a look at your solder connections and touch those up. So I'm going to drop in the new 0.1 microfarad cap here, which is a beautiful Sprague. And then we'll change out the two grid caps. Now these are 0.25 microfarad 600 volt caps. I'm going to replace them with 0.22 microfarad 600 volt caps. There's absolutely no difference in the sound or the performance of the amp by changing it with the 0.22s rather than the 0.25s. Alright, we have our new Sprague caps installed on the driver board, so we're getting close to the point of popping in the tubes and bringing her up. But one thing I needed to bring up, take a look here, you can see it still has the old style 2-conductor ungrounded AC power cord. That is how you want to keep this amp. Do not put on a 3-prong grounded type cord, because what happens is you're going to get into a big ground war between your preamp and this amp, and you're going to have an out of control hum monster. There's a reason that Dynaco kept this as a 2-conductor AC cord. Leave it that way and avoid yourself some heartache. Alright, so here we go. Initial power up. Now I've got the output of the amp hooked into the D-lab audio test set, so this is providing an 8 ohm load. This meter is monitoring the bias, and I put in some sacrificial 6550s, and you can see they've been around a while, some old RCAs. We're on the Variac, so I'm going to bring up the voltage. There's about 70 volts right there. Now what we're waiting to see is for the bias numbers start coming up on this meter. Help if I don't knock my ground lead off. There we go. So right now, I know we got some glare off of my light. Maybe that'll help. Put something back there so it doesn't fall. Okay. So we're warming up. I'm pulling current. There's no fire. You can see the meter starting to read. That's good. So that is the bias through the two 6550s as they're warming up. So what I'm interested in is, can I adjust that bias? So we're going to wait for this to stabilize, and then I'll take my little tweaky-doo-dah and we'll go back to the bias pot and see if I can vary that bias. And once it comes up and things are stable and I don't see this bias moving, then I'll put in the new gold line tubes. We'll rebias the amp and throw some audio through it. So you can see we've stabilized about 0.76. Now the bias set is 1.56 volts or so, but remember, I'm on the Variac and I'm only at about 90 volts. Okay, so you're not going to see the full bias. Now I'm in the bias pot, and yep, I can adjust it. So that's a good thing. Next step, let's put in the gold lions. So here they are, a beautiful set of Genelix Gold Line KT-88s. These are my go-to tubes for Dynaco amps. These aren't too hot anymore. Still a bit warm, but not bad. Anyway, when I rebuild these monoblocks, these are my tube of choice. They have a great tone. They're very robust. I've had a set in my monoblocks for about 2 years. Never had an issue. They sound as good as the day that I put them in. Anyway, get our new tubes in, seated. Let's bring it up on the Variac real slow like we did before and set the bias. Now the rectifier tube was still warmed up, but now we're waiting on the new KT-88s to warm up before we start seeing that bias number. And this is where you really want to be careful. If you see that bias take off for any reason, that could indicate a bad tube, because we know that with the old sacrificial tubes, the bias came up and it stabilized. So even though they are new tubes, they could have a problem. So you got to keep an eye on that. Here it comes. I'm back to about 90 volts like we were before. Now I didn't check these old RCAs. I have not tested these yet, but when we get done I will, for the heck of it. See if they had any life left in them. So I'm just going to watch this voltage coming up, and eventually it's going to stabilize. But before I see that, I'm not going to apply full voltage to this amp. So this is one advantage to having a variac, guys. You can really control your initial power up of these amps and possibly protect them from damage if you can catch it quick enough. Okay, so we see you got about 0.85 volts. We know our normal bias is 1.5 volts, so we can easily advance our power up. Okay, so now I'm at about 100 volts. Alright, so at this point I think it's safe to power this guy up full 120. Alright, moment of truth. I'm going to flip on the power switch. We're plugged right into the 120 like you would do at home. I'm going to flip it on. We're going to watch the bias. And then I'm going to dial it in. And we're not going to let it exceed the 1.5 volts. I actually like to run them a little colder than the 1.5 volt bias, because you got to remember, back in the day the line voltage was not 123 volts like it is today. So that bias of 1.5 volts could actually be a little high for those tubes. Here we go. 1.4. Look at there. I'm going to tweak the bias down a little bit. Okay, good. This is critical, guys. If you see this bias jumping when you're adjusting this pot, shut it off. Clean the pot, check connections. It needs to come up and stabilize. I like 1.44. That's where I'm going to leave it. So next step, let's put some audio through this thing and look at it on the scope. Alright, so the bench got a little bit busy here because I had hooked up my test set, audio generator, monitor the bias, of course the amp, and now we have a scope. You can see a slight little sine wave here because my audio generator doesn't actually go to zero output, but right there I'm driving the amp. Okay. If you look at the audio test set up here, you can see I'm putting out just over a watt of power, but we are getting audio through the amp. Now, I'm not going to master blast this thing, alright, but we will make sure that it's got good, clean, stable output. You can see my biases went up to about 1.51. That's because we're applying a signal, and now the tubes are starting to do a little bit of work, right? So I will be readjusting that bias when I'm done. But it's looking good. Vary the frequency here. Clean, pure sine wave. So it looks as though this Mark III is back up for the task. I got to get Unit B set up. I'm not going to go through the same thing on Unit B and show all that because it's just going to be a repeat. However, if I find any issues, I'll bring that up further down here in the video. Right now, I'm very happy with the performance of Unit A. It's going to be a great machine for the new owner. Well, I ran into a problem on Unit B. I put in the old sacrificial tubes and she biased right up. I put in my second set of Gold Line KT-88s. No bias, just laid at 0. I was like, what the heck's going on? Well, here's what's going on. The filaments are open on the second set of KT-88s. I don't know how that could be. They both came in the same box. With the other two tubes, it was a matched quad. So maybe rough handling, I'm not sure. But my emissions on these are 0 and no filaments. So in other words, I can't finish Unit B until I get new KT-88s. That's a bummer. So as I promised, here is the first set of KT-88s or 6550s that was in the amp under test, just to see if they had any life. She's warming up and you can see the filaments in there, and she is getting warm, whereas those two guys are cold as cucumbers. I'm still pretty baffled about that. Anyway, here's the test. Let's see how these do. So there's no leakage, that's a good thing. There's my plate current, about 109 milliamps or so. And here in a second, it should show us the output of the tube. About 78% emissions. So they're used but usable. However, they won't go back in the Dynacos. So here's amp Unit B running with those old tubes in it. You can see she biased up. You can hear them kind of pinging. But at least it's working. So I'll have to get another set of the Red Lions and we'll go from there. But the new caps are installed and everything else on this amp checks out fine. So just for reference, here is another 6550 that I had laying around. The filaments are 2 and 7. You can see the resistance there on the meter, a little under an ohm. So here are one of the new Gold Lions. Same deal. We'll go from 2 to 7. Open. Bummer. Here is Gold Line number 2. Same deal. 2 to 7. Wide open. I have no idea how it could have happened. You don't hear anything. It's just the filaments are open. So either it was that way when they were made at the factory or something happened in shipping, because I've never had an issue with these tubes. So this is a surprise to me. So it looks like we'll be returning these defective Genelex tubes. Hopefully the place we got them from will be cool about it and just refund us. I'm sure that if I got a set with open filaments, other people are getting the same thing. So it shouldn't be a big deal. It's just going to take a little more time. Anyway, we got through the first amp flawlessly, and I hope that these tips I'm giving you will help you in case you run across one of these old relics and you want to bring it up safely. Whatever you do, do not ever take an amp like that and just plug it in the wall and cross your fingers, because more than likely you'll damage the amp. Take your time, do it right. That's the best advice I can give you from D-lab. We'll see you.